Okay, in this video, this is going to be part 2 of section 4.2, dealing with the mean value theorem. And I just need to cover part C of examples 5 and 6. Now, I've already done part A and B, so if you want to look at that, there is the previous video for it. So you might want to look at that to see how I did those, how I found out that the function in this case, in example 5, f of x equal to 4 minus x squared, it is continuous on the closed interval -1, 2, and differentiable on the open interval -1, 2. Here, both conditions are satisfied. That means that the mean value theorem can be applied. And then also, I found out the value or the points that's guaranteed to exist by the mean value theorem using this relationship, because I had to find out what value C such that f of b minus f of a divided by b minus a would be equal to f prime of C. And here I found out what f of a is and f of b was. In this case, a was -1 and b was 2. So f of -1 would be 3 and f of 2 would be 0. All right, and f prime of C will be -2c, since f prime of x came out to be 2x for that function. Then I substituted into this equation to come up with C is equal to 1/2. That would be the point that's guaranteed to exist by using the mean value theorem. Now in part C, I need to show you how to make a sketch of the function and the line that passes through a f of a and b f of b. Then mark the points P if they exist, at which the slope of the function equals the slope of the tangent line. Of the secant line, and then sketch the tangent line at P. All right, so this will be part C. And I'm going to first graph the function f of x is equal to 4 minus x squared. All right. So this right here is going to be part C, where I'm going to graph the quadratic function, because that's what it is. F of x is equal to 4 minus x squared. All right, now what you can do if you like is use your graphing calculator and the table. So in this case here, let me go to y equal 2, and I'm going to clear this equation out and type in 4 minus, and then get the x for the x, and then x squared to square it. Then I'm going to do second and graph for the table. And I'm going to use points like, let's say -2, -1, 0, 1, and 2 as x values. All right, so at -2 is going to be 0. And at -1, that's going to be 3. And at 0 is going to be 4. And at 1 will be 3. And at 2 is 0. And if I want to, I can use, let's say, I'll use -3 as well. That's going to be -5. And at +3 is going to be -5 as well. So pretty much the graph is symmetric about the y-axis, as you might guess. All right, so now I'm going to use a different color to graph the function f of x equal to 4 minus x squared. So -2, 0 will be here. -1, 3 will be up here. 0, 4. 1, 3, and 2, 0. Also -3, -5 would be down here. 3, -5 would be down here as well. So pretty much you can see the symmetry here. And the graph is going to look like this. All right, so that's the graph of f of x equal to 4 minus x squared. All right, next I need to come up with a line that passes through a f of a and b f of b. All right, so AF of A, and then B, F of B. All right, in this case here, going back to part B, my A was -1, and I found F of -1 or F of A to be 3. So that ordered pair would be -1, 3. And for B, F of B, let's go back up here. B was 2. So B was 2. F of B or F of 2 was 0. So in this case here, that ordered pair would be 2, 0. All right, in this case here, I'll plot those on the coordinate plane. And I'm going to use a different color here. Let's see if I can I'm going to use red. So for -1, 3 will be this point right here. And 2, 0 will be this point right here that I'm coloring in red. And I'm going to connect those two. This will be the secant line, because the secant line crossed the graph through 2 points. So that's the secant line there. I don't care what the equation is. I just want just a graph of that secant line. All right. And now they want the tangent line at P. Okay. Now back in part B, we found out what C was. That was 1/2. So F of C, since F of X was 4 minus X squared, F of C in this case will be 4 minus C squared. And here F of 1/2, since C is equal to 1/2, we just substitute that C with the 1/2. So it'll be 4 minus 1/2, and that's going to be squared. All right, so let me go to this screen. Let me clear this out. This will be 4 minus left parentheses 1 divided by 2 for 1/2, and then X squared to squared. That would be 3.75. Now, of course, if you want to convert that to a fraction, we can do the math key and then select number 1 for fraction, and that would give us 15/4. So we can write this ordered pair as 1/2, 15/4. That's going to be the point on the graph of that equation, or that function that's in blue. All right, so I'm going to use different color to draw the point 1/2, 15/4. And 15/4 is 3.75. This is halfway between 0 and 1. 15/4 would be 3.75, which will be about right here. So here's that point. And I'm going to draw the secant line that's going to be parallel to, the tangent line that's parallel to the secant line, like this. So this graph that I'm drawing, this line in orange, represents the graph of the tangent line, and that tangent line is going to be parallel to the secant line, meaning it's not going to cross each other. Okay, so that right there is part C of example 5. Okay, and also, of course, in the homework, you're going to choose pretty much one of those graphs that fits the one that I have here. And in this case, it's going to be, well, based on this, it will be answer choice B, because you can see the graph of the secant line, and then the lighter line would be the graph of the tangent line. And that parabola does open downward. Okay, now let me go over example 6. Example 6, pretty much for parts A and B, I did in a previous video. So if you want to see how that's done, you can pretty much watch that video there. But here, this will be part C. I do have my graph, my coordinate grid here. This is where we make a sketch of the function and the line that passes through A, f of A, and B, f of B. Mark the points P if they exist, at which the slope of the function equals the slope of the secant line, and then sketch the graph of the tangent line at P. All right, so let's go ahead and graph f of x equal to e to the x. So this is part C. And that was the function there to begin with, f of x equal to e to the x. The interval is from 0 to ln of 5, by the way. So let me draw a table, x and f of x. Now here I'm picking values like -2, -1, 0, 1, and 2. Okay, I'm picking conservative x values here. And I'm going to show you why. If I go to y equal 2, clear that equation out in y1, I'm going to do second ln for the e, get the x, and then I'm going to do second and graph for the table. And I'm going to start with -2. In this case, that's going to be approximately 1/10. I'm rounding to one decimal place. So at -2 will be 0.1. And at -1, that would be approximately 0.4. At 0 is going to be 1. And at 1, it's going to be 2.7, approximately. And then for 2, it will be 7.4, approximately. Now, if I use 3, that came out to be like 20.086. And that's too big because my coordinate grid is only limited from -10 to 10 on the x and -10 to 10 on the y. So let's use those. Okay, so I'm going to graph this in blue. So in this case here, -2 and then -0.1. That's almost near the x-axis. And then -1 to 0.4, be about right here. 0, 1 would be on the y-axis. 1 and 2.7 would be approximately here. And 2 and 7.4, that's going to be up here because e to the x, it goes upward. It goes astronomically up like this. And coming this way, it approaches the x-axis. It's closer and closer to the x-axis. So that's the graph of f of x is equal to e to the x. All right. Now I need to come up with a line that passes through A, f of A, and B, f of B. Okay, so let's find out what A, f of A was. This is from part B. A was 0, so f of A ended up being 1 when I substituted into e to the x. So that ordered pair is 0, 1. And then I need my B, f of B. All right, for f of B, that came out to be, the B was ln of 5, so f of B came out to be 5. So my ordered pair for that would be ln of 5 and 5. All right, so let's go here, go to the home screen. If I do ln of 5 on the calculator, to one decimal place, that'll be approximately 1.6. So my ordered pair would be approximately 1.6 and 5, since ln of 5 is a constant. All right, so now let's plot those, and I'm going to use red here. Let's see, 1.6 will be to the right, 1.6 about right here and up to 5. So that would be this point right here. And 0, 1 would be this point right here. And then if I connect those 2 points on the coordinate plane, this will be the equation for the graph of the secant line. Okay, so here you go. That's the graph of the secant line. All right, now the point P in which the slope of the function equals the slope of the secant line. So here back in part B, which I did in a previous video, I found C to be the natural log of 4 over ln of 5. All right, so that's what C is. Now, of course, my f of C was e to the power of C. Here it is. F of C was e to the power of C. So let me okay. So I'm going to be finding f of ln of 4 over ln of 5. And that's going to be equal to, since f of C is e to the power of C, this will be e to the ln of 4 divided by ln of 5. Now, there is a property that says if you have e to the ln of whatever, that's going to be equal to whatever, since e and ln are inverses of each other. So e to the ln of 4 over ln of 5 ends up being 4 over ln of 5. All right, so the ordered pair is going to be C, f of C. So the C in this case is ln of 4 divided by ln of 5, and then comma f of C, which is 4 ln of 5. Let's find out what these are as decimals, so that way I can plot that on the coordinate plane. If I do ln of 4 divided by ln of 5, this will be pressing the ln key, then 4 divided by ln again, 5, close the parentheses around the 5, and then close it again for the first parentheses after the first ln. You'll get to one decimal place, 0.9. So my x-coordinate there will be 0.9. And then for ln of 5, I'll just do, 4 divided by ln of 5, that'll be 4 divided by ln 5, close parentheses. This will be approximately to one decimal place, 2.5. So this I will plot on the coordinate plane, and I'm going to use an orange color for that. I'll tell you what, I use green. 0.9 is almost to 1. And then 2.5 would be about let's say about right here. Reality is not exactly 2.5, it's just 2.485. And if I draw that tangent line, has to be parallel to the secant line. This will be it. That green line represents the tangent line to the curve f of x is equal to e to the x. Okay. I had to do it on paper because it's hard for me to do it on the graphing calculator, by the way. And if you were to plot this, well, if you were to do this for the homework, you'd be given a choice of answers. And in this case, it would have to be choice B. Here they're using a range of X values from 0 to 2 and a range of Y values from 0 to 8. Okay. So hopefully this will help you to complete part C of examples 5 and example 6 in section 4.2 dealing with the mean value theorem. Feel free to contact me if you have any questions.